10,000 chat transcripts, 3 scenarios, and no data scientist. Are customers happy? What topics keep recurring? Is there personally identifiable information in those logs? 3 API calls answer all 3, no model training required. You're in the right place. This is Amazon Web Services AI Practitioner Prep. By the end of this video, you'll be able to read a scenario and instantly name the right Amazon Web Services managed AI service. No hesitation between Comprehend, Textract, Rekognition, and the rest. These are 9 pre-built services that add intelligence to an app without training a single model. In the last few episodes, we built the mental model of how machines learn. Episode 2 nested artificial intelligence, machine learning, deep learning, and generative AI inside each other. Episode 3 sorted the ways a model learns, and Episode 4 covered how you evaluate one. Now we shift from theory to the toolbox. These are the services you reach for when you don't need to train anything at all. 5 terms will carry us through this whole episode. A managed AI service is a pre-built service you call through an API. No model training, no machine learning expertise. Automatic speech recognition, or ASR, is the technology that turns spoken audio into text. Natural language understanding, or NLU, figures out what a user actually means from their words. Intents and slots are the 2 building blocks of a chatbot. An intent is what the user wants, and slots are the details the bot has to collect. And semantic search matches on meaning instead of exact keywords, so a plain English question returns the passage that genuinely answers it. Here's the mindset shift for this episode. Beacon Labs doesn't need to train a custom model to pull text off a scanned consent form or detect what language an incoming document is in. Amazon Web Services already built purpose-specific services for those exact tasks. 9 of them, all pre-trained, all pay-as-you-go, and none requiring any machine learning knowledge to use. The whole game is knowing which one to reach for. 9 services sounds like a lot to hold in your head, so let's give them structure. They split cleanly into 4 clusters. The language cluster handles text and speech. That's comprehend, translate, and transcribe. The document and vision cluster reads documents and images, Textract and Rekognition. The conversational and search cluster covers Lex and Kendra. And the speech and recommendation cluster gives us Poly and Personalize. We'll take them one cluster at a time. Before we get into the services, here's the single reflex that answers most exam questions in this family. Every scenario hands you 2 things: what the input is and what output the business needs. Audio going in, text coming out. An image going in, labels coming out. Your job is just to name the service that sits between them. Master that mapping, and these questions become almost mechanical. First up, Amazon Comprehend. Think of it as text in, insights out. You feed it text you already have, and it pulls out the entities mentioned, the key phrases, any personally identifiable information, the dominant language, and the sentiment, positive, negative, neutral, or mixed. It's serverless, natural language processing that works out of the box. And if you need it, you can train custom classification or entity models with AutoML. No machine learning expertise required. Reach for comprehend when you already have text and you need to understand its meaning at scale. That support manager from the opening, Comprehend answered all 3 of her questions. The clearest way to picture Comprehend is a literary critic. You hand it a finished book and it tells you the mood, the themes, and who the characters are. What it never does is write new text or ask you a question back. That passive, read-only nature is exactly what separates it from the conversational services we'll hit later. Comprehend reads what's already there. Here's how the Comprehend Developer Guide puts it. It uses natural language processing to extract insights about the content of documents by recognizing the entities, key phrases, language, and sentiments. Notice the verb there, extract insights. It's pulling meaning out of text that already exists. That's the anchor for every comprehend scenario you'll see. Next in the language cluster is Amazon Translate. Text in one language goes in, the same text in another language comes out. It's neural machine translation across 75 languages and more than 5,500 language pair combinations, available in real time or in batch. One feature worth remembering is custom terminology. You upload a list of your brand names and proper nouns, so they don't get mangled in translation. Reach for translate whenever text needs to move between languages. On the exam, it usually shows up as one step inside a bigger pipeline rather than on its own. The third language service is Amazon Transcribe. This one is audio in, text out, automatic speech recognition. It works on batch files sitting in S3 or on real-time streaming audio, and it bills per second with a 15-second minimum per request. It can tell speakers apart with diarization, handle custom vocabulary, redact personally identifiable information, and even identify the language automatically. Two variants matter. Transcribe Medical is HIPAA eligible but supports only US English, and Call Analytics adds sentiment scoring and generative AI summaries for contact centers. Here's a pairing the exam loves to blur, so lock it in now. Transcribe and Poly are exact inverses of each other. Transcribe listens to someone speaking and writes down what they said, meeting captions, call transcripts, anything where the cue is convert recordings to text. Poly does the opposite. It reads written text aloud and produces a lifelike voice file for narration, accessibility, or phone system prompts. The cue there is make the app speak responses aloud. Audio to text is Transcribe. Text to audio is Poly. Quick consolidation before we move on. Comprehend understands the meaning in text you already have. Translate moves text between languages. And Transcribe turns speech into text, while Poly runs that in reverse. That's the language cluster locked in. Now let's leave text behind and look at services that read documents and see images. Amazon Textract pulls structured data out of documents. It extracts typed and handwritten text, but the important part is that it also captures form fields, tables, and key value pairs from images and PDFs. This is what takes it beyond plain optical character recognition. Textract doesn't just read the characters. It understands that the value next to line 7 belongs to other income, mapping each label to its value. It also has specialized workflows. Analyze expense for invoices and receipts, Analyze ID for US government IDs, and Analyze lending for whole mortgage packages. For Beacon Labs, this is exactly what reads a scanned consent form. Amazon Rekognition is the computer vision service. Its input is a raw image or a video stream, and it uses deep learning to detect objects, scenes, faces, and even tens of thousands of celebrities without you supplying any names. It flags protective equipment like hard hats, and it moderates unsafe content. Picture a security guard reviewing footage, spotting who came through the door, flagging anyone without a hard hat, and reading the sign above the entrance. That last part matters. Rekognition can detect text in a natural scene, like a banner or a license plate, and return the raw strings. Reach for it whenever the input is an image or video. Both Rekognition and Textract can read text, so how do you tell them apart on a question? The discriminator is structure. If you photograph a street corner, Rekognition reads the text on the stop sign and the billboard, raw strings from a natural scene. But if you scan a tax form, Tour Extract not only reads the numbers, it understands that a particular value belongs to a particular labeled field, preserving the form fields and tables. So the rule is simple. Text in a scene means Rekognition, Text inside a structured document means Textract. One recognition capability deserves a concrete look before we move on: content moderation and what its response actually looks like. It returns hierarchical labels with confidence scores. You can see graphic nudity nested under the broader explicit nudity category, each with its own confidence. The pattern most platforms build around this is straightforward. High confidence violations get auto-rejected, and the low confidence borderline cases get routed to a human reviewer. So one API call becomes an automated moderation gate for every video upload. Now the conversational cluster. Amazon Lex builds chatbots using the very same speech recognition and language understanding technology that powers Alexa. Its two core concepts are intents, what the user wants to do, and slots, the parameters the bot has to collect to do it. One currency note: always use Lex version 2. Version 1 reached end of support in September 2025, so any current reference to Lex means version 2. Reach for Lex when you need a structured, back-and-forth dialogue that gathers information from a user, one turn at a time. Picture an airport check-in kiosk. It walks you through a fixed script: your booking reference, your seat preference, how many bags. That's the intent, and those requests are the slots it needs to fill. What the kiosk won't do is answer an open-ended question or browse the web. That's Lex? Exactly. It runs a bounded, structured conversations. The moment a scenario needs free-form generative chat instead, you're looking at Amazon Bedrock, which we'll cover in the next module. Amazon Kendra is intelligent enterprise search. Think of a company librarian who's read every internal report and policy document and can answer a plain English question like, "What's our parental leave policy?" by pointing you to the exact paragraph. That's Kendra, semantic search over an index document corpus, returning the precise passage rather than a bag of keyword matches. One lifecycle fact to know: Kendra entered maintenance mode on June 30th, 2026, and stopped accepting new customers on July 30th. Amazon Web Services now recommends Amazon Bedrock knowledge bases for new builds. But for the exam, Kendra is still in scope as the enterprise document search service. The official notice says it directly. What that means for your exam: Kendra is enterprise semantic search over internal documents using managed connectors. It handles the indexing and ranking for you. Bedrock Knowledge Bases is the modern replacement for any new build. If a scenario describes an existing deployment querying internal content, think Kendra. If it describes something being built today, think Bedrock Knowledge Bases. Let's pause and take stock. Textract reads document structure, while Rekognition analyzes images and video. Lex runs a structured dialogue with a user, and Kendra searches a document library. That's 7 of the 9. 2 remain to complete the set: Polly on the speech side and Personalize for recommendations. Let's finish them off. Remember Polly from the Transcribe inverse. Here's the full picture. Amazon Polly turns text into lifelike speech. It offers over 100 voices across more than 40 languages, spread across 4 engine tiers: standard, neural, long-form, and generative. You get fine control through speech markup, and it's HIPAA and PCI eligible. One style worth knowing: the newscaster speaking style, which gives responses a broadcast news quality. That style is only available on the neural engine. It's not supported in the generative engine, so if you're building on generative and expect newscaster, it won't work. Here's a genuinely useful detail regardless of engine. Once Polly synthesizes an audio file, you can cache and replay it at no extra synthesis charge. Narrate a product description once, and you serve that audio to millions of listeners paying for exactly one synthesis call. Reach for Polly whenever you need voice responses, narration, or accessibility for visually impaired users. The last service is Amazon Personalize. It's the one managed service built purely for individualized recommendations. It ingests user interaction data, clicks, purchases, streams, and produces recommendations in real time or in batch. It ships with domain recommenders tuned for specific use cases, top picks, and more like this for video streaming, and frequently bought together for e-commerce. Reach for Personalize whenever a scenario mentions personalized recommendations, collaborative filtering, or a next best action for a specific user. Signal words like users who bought this also bought that point straight here. There's a secondary confusion pair worth heading off: Kendra versus Personalize. Kendra takes a natural language question and returns a document passage. It's about finding an answer that already lives in your docs, and it returns the same answer to every user asking the same question. Personalize takes a user's interaction history and returns a ranked list of items tailored to that one individual. So if the goal is find the answer, that's Kendra. If the goal is suggest what the specific user will like, that's Personalize. Now the most valuable 30 seconds in this episode, the 4 services candidates confuse the most. Run this decision tree top to bottom. First, is the input an image or video? If yes, it's Rekognition and you're done. If not, does the scenario involve a back and forth dialogue with a user? That's Lex. Still no? Is the goal to search inside existing documents? That's Kendra. And if none of those fit, and you simply need to analyze the meaning in a block of text, that's Comprehend. One warning at the bottom: text inside an image is still Rekognition, not Comprehend, because the input is visual. The reason these 4 trip people up is that several of them touch language, so the words blur together. Here's the cleanest cut. Both Comprehend and Lex deal in language, but Comprehend analyzes text you already have, while Lex collects information from a user through a structured conversation. One is passive analysis, the other is an active dialogue. If you can state that difference in one sentence, you'll pick correctly under pressure. These services rarely work alone. They chain into pipelines, and the exam tests that awareness too. Take speech-to-speech translation. Transcribe turns spoken audio into text, Translate converts that text into another language, and Polly speaks the result aloud. 3 services, 1 seamless flow. Or take document intelligence. Textract extracts the text and structure from a scanned document, then Comprehend analyze that text for sentiment and entities. Recognizing the chain is often the real skill a scenario is testing. That document pipeline hides a mistake worth flagging. Comprehend's built-in features take UTF-8 text as input. It does not read images or PDFs directly. So if a scenario says analyze the sentiment of a stack of scanned forms, you can't point Comprehend at the scans. You extract the text with Textract first, then hand that text to Comprehend. Miss that ordering, and you'll pick a 2-service answer where the exam wanted you to notice the extraction step. Here's the whole family on one card, framed by input and output. Comprehend takes text and returns insights like sentiment, entities, and personally identifiable information. Translate takes text and returns it in another language. Transcribe takes audio and returns text, while Polly does the reverse. Textract takes a document and returns structured data, while Rekognition takes an image or video and returns visual labels. Lex takes a user utterance and runs an intent and slot dialogue, while Kendra takes a question and returns a document passage. And Personalize takes user behavior and returns ranked recommendations. If you remember nothing else, remember the big 4 decision tree and this input-output table. Now let's test all of this with a quick 5-question quiz. When input and output alone don't separate 2 services, look at output structure. Textract and Rekognition both take images, but Textract returns extracted form fields and key value pairs, structured data. Rekognition returns labels and scene categories. Unstructured. Structured output narrows to Textract every time. Let's test what you've learned. A company receives thousands of customer product reviews as text each day and wants to automatically classify each one as positive, negative, neutral, or mixed. Which service fits best? Is it A, Amazon Lex, B, Amazon Comprehend, C, Amazon Kendra, or D, Amazon Transcribe? Run the input-output reflex before you answer. This one is B, Amazon Comprehend. The input is text you already have, and the output you need is sentiment. That's Comprehend's core function. Lex builds conversations. Kendra searches a document corpus, and Transcribe would only apply if the reviews arrived as audio. Question 2. A logistics team photographs shipping labels stuck on boxes across a warehouse floor and needs to read the text printed on each label straight from those photos. Which service should they use? A, Amazon Comprehend, B, Amazon Poly, C, Amazon Personalize, or D, Amazon Rekognition. Think about which constraint matters most here. The right call here is D, Amazon Rekognition. The input is a raw photograph, and text in a natural scene is read by Rekognition's text detection. This is the classic trap because the word text appears. Comprehend feels tempting, but Comprehend can't read an image at all. Visual input means Rekognition. Question 3. A hospital wants its employees to ask natural language questions, like, what's our infection control policy for isolation rooms? And get back the exact answering passage from a large library of internal policy documents. Which service is the classic fit? A, Amazon Kendra, B, Amazon Personalize, C, Amazon Lex, or D, Amazon Textract. Lock in your answer before I give it away. If you said A, Amazon Kendra, well done. The goal is searching inside an index document corpus and returning the relevant passage. That's Kendra's whole purpose, with Bedrock knowledge bases as the modern successor for new builds. Lex would run a bounded dialog, not an open search, and Textract only extracts text from documents rather than answering questions about them. Question 4, and this one tests pipeline awareness. A French-speaking user records a voice message, and the team wants it played back to an English-speaking recipient as spoken English. Which chain of services does this end-to-end? A, Comprehend, then Translate, then Poly. B, Poly, then Translate, then Transcribe. C, Transcribe, then Translate, then Poly. Or D, Transcribe, then Comprehend, then Poly. Got your pick? Let's see. The answer is C, Transcribe, then Translate, then Poly. Start with audio. So Transcribe converts the French speech to French text. Translate turns that into English text. And Poly speaks the English text aloud. Comprehend would only analyze meaning, which isn't a step you need here, and option B reverses the whole flow. Let's test a concept from an earlier episode tied to today's material. A scanned patient consent form needs to be analyzed for sentiment and named entities using a managed Amazon Web Services service. What must happen before Comprehend can process it? A, the form must first be summarized by a foundation model on Bedrock. B, the text must first be extracted from the scan using Textract. C, nothing. Comprehend reads the PDF scan directly. Or D, the form must first be clustered into cohorts using k-means. Pause here if you want more time. If you said B, well done. Comprehend's built-in features accept plain UTF-8 text, not images or PDFs. So a scanned document has to go through Textract first to pull out the text, and only then can that text be handed to comprehend. This Textract then comprehend ordering is the exact pipeline nuance the exam likes to check. And that closes out Amazon Web Services Managed AI Services, the Language and Vision family. If it made the topic click, do me a favor and subscribe. It's what tells YouTube these lessons are worth showing to other learners. Tell me in the comments what stuck and what didn't. If there's a cert you're chasing that I haven't built yet, request it below. That list shapes what I make next. And honest notes on the pace or the visuals are always welcome. Until next time.